You know that incredible burst of color we see every fall? Ever wonder what's really going on there? Well, it's not just some kind of magic. It's actually this brilliant chemical strategy for survival. So let's get into it and break down how this whole amazing process works. Yeah, so that's the big question, right? Why do leaves, which are just green all summer long, suddenly put on this spectacular show, this incredible canvas of reds, oranges, and yellows? Well, that's exactly the mystery we're going to unravel today. Okay, so here's the interesting thing. To really get what's happening in the fall, we actually have to rewind and start back in the summer. Because the whole story of those autumn colors, it really begins with that deep, vibrant green that we see everywhere in the warmer months. All right, so the star of the summer show is this pigment called chlorophyll. And this stuff is an absolute powerhouse. Its job is to soak up red and blue sunlight for energy. But, and this is the key part, it doesn't care about green light. It just reflects it right back out. And that reflected green light, that's what our eyes see, and that's why leaves look green to us. You know, a really good way to picture this is to think of every single leaf as its own tiny, bustling, solar-powered factory. Seriously, all summer long, it is just cranking out sugar to feed the tree. And chlorophyll, that's the essential machinery inside that factory that makes the whole operation run. But here's where it gets really cool. That overwhelming green color, it's actually a disguise. Yeah, hiding just underneath the surface. There are other colors, other pigments, that have been in the leaf the whole time, just waiting in the wings for their big moment. So what are these hidden pigments? Well, they're called carotenoids, and they're the ones that create those yellow and orange colors. Just think of carrots or corn, same kind of pigment. The wild part is they're in the leaf all year long, but you just can't see them. They are completely overpowered, totally masked by the massive amount of green chlorophyll being cranked out during the summer. So what flips the switch? I mean, a tree doesn't just wake up one morning and decide, you know what? Today's the day to change colors. No, it's actually listening. It's responding to very specific signals from the environment that are telling it, hey, winter's coming.
And what are those signals? Well, there are two main triggers: how long the days are and the temperature. But the biggest one, the most important signal by far, is the daylight. As the days start getting shorter and shorter, the tree gets the message loud and clear. It's time to start shutting down for the season. And yeah, that cooler air helps slow everything down too.
So getting these signals, the tree makes a really crucial decision. It's like, all right, time to close up shop. The food factory is officially closing down. It systematically stops making new chlorophyll. And since chlorophyll is pretty unstable and breaks down fast without a lot of sunlight, that green color starts to fade. And just like that, the stage is set for the next act. Okay, and this is where the real magic happens. As that green fades away, boom, the fall colors start to emerge. But here's something you might not know. They don't all show up in the same way. There are actually two totally different processes at play that create the spectacular colors we see. So, first up, let's talk about the colors that, well, aren't new at all. Remember those pigments we mentioned? The ones that were basically hiding in the leaves all summer long? Well, it's finally time for their grand entrance. This is the crucial part. Those brilliant yellows and oranges you see in trees like aspen, birch, and hickory, they come from those carotenoids. All that's happening is that the dominant green chlorophyll is breaking down and fading away, and ta-da, these underlying pigments are finally revealed. So it's not really about creating a new color. It's more like an unveiling. But wait a minute, what about those fiery reds, those deep, rich purples? Now that is a completely different story. See, unlike the yellows and oranges, these pigments weren't just hanging out all summer. Nope, they are made fresh, specifically for the autumn show. It's like there's a special recipe for making red. Step 1, you need bright, sunny autumn days. That lets the leaves keep making sugar. Step 2, you need cool nights, but not freezing. That chill is what traps all that sugar inside the leaves. And it's that exact combination, lots of sun, lots of trapped sugar, that triggers the leaf to create brand new pigments called anthocyanins. And that's what gives us those spectacular reds and purples you see in trees like maples. All right, so after the big color show is over, the leaf has one final act. It falls from the tree. And it's easy to see this as, a sad thing, like a sign of decay. But it's not at all. It is a carefully planned final step in the tree's master strategy to survive the winter. So how does it do this? The tree actually grows this special layer of cells right at the base of the leaf stem, right where it connects to the branch. This thing is called the abscission layer, and its one and only job is to create a nice, clean break, separating the leaf from the rest of the tree.
A great way to think of it is like the tree is sealing up its doors and windows for the winter. It's basically creating a little protective scar that's going to shield it from all the harsh conditions that are on the way. And why is that so important? Well, this seal is absolutely vital. For one, it stops the tree from losing precious water through its leaves all winter long. And just as important, it protects it from diseases or fungi that might try to sneak in through an open wound. Pretty smart, huh? So when you step back and look at the whole cycle, I mean, from shutting down the green chlorophyll to revealing those hidden colors and then finally letting the leaf go, it's all one big, incredibly efficient strategy. The tree is pulling back valuable nutrients, conserving every bit of energy it can, just to make sure it has everything it needs to survive the winter and then burst back to life in the spring. And that kind of leaves us with this final thought, doesn't it? We so often think of autumn as an ending, the end of growth, the end of the warm season. But when you really understand the chemistry behind it, you start to see it in a whole new light. It's not an end at all. It's the tree's brilliant, beautiful first step in getting ready for a brand new beginning.